Hello everyone. We Team Zenith are going to present our project NanoNavix, an AI-powered navigation error recovery for wafer inspection. The novelty of our system is it is an hybrid ZNCC plus Siamese CNN visual localization system enhanced with a pi feedback controller that continuously reduces localization error for precise navigation correction. So let's see how our project works. So this will be our input, this will be our input reference image, and this will be our input search image. And let us run our system. I will test with the 34th image. Yeah, you can see this. So the first step is the visual localization. First, the system performs visual localization. So we provide two images, a reference image containing the target pattern and a large search image containing many repeating structures. The main challenge is that many regions of the wafer look almost identical. Therefore, a simple template match may produce multiple possible locations. Our first stage uses zero mean normalized cross correlation to generate the top candidate regions from the search image. In our implementation, we generate the top 50 candidate regions. These candidates are then passed to a Siamese CNN verifier which compares the reference image with each candidate patch. The CNN assigns a matching probability to every candidate, and the candidate with the highest probability is selected as the predicted target location. So you can see over here the results of the visual localization. And then the next part is this actually consists of three parts. In the first part, it consists of visual localization as well as the navigation error part. And then when we come to the navigation error part, once the target has been localized, we calculate the navigation error between the predicted position and the desired target position. The error is calculated independently along the x and y axis. The Euclidean distance gives us the overall positional error. You can see over here. Next comes our pi controller. The second stage is the pi controller. The purpose of the pi controller is not to improve the CNN's classification or localization accuracy. Instead, it converts the localization error into a navigation correction. The proportional term responds to the current error. If the stage is far from the desired position, it produces a larger immediate correction. The integral term accumulates the error over time. This allows the controller to compensate for persistent systematic drift and reduce steady state error. You can see it over here. You can see the correction over here. Now the final step, it's the control loop. Basically the final stage is a simulated closed loop. Since this prototype is not connected to a physical motion stage, we simulate how the stage would respond to the pi correction. You can see the final results over here. Initially we had 0.4 error for 0.4 pixel error at the time of visual localization. See over here. After the first step, this is what we have, 0.4 pixels, and then at the end now we have 0.04 pixels. So which is, we have reduced 88% error, and this is the final position. And then here we have the results. Yeah, this is the 34th image result. This will be our main output. This is the predicted one. You can see it over here, the ground truth, and the one predicted by the Siamese CNN. and the one by which is the pi corrected one. And then the main part is the pi control loop convergence curve. This curve shows the convergence of the pi based navigation control loop. The x-axis represents the control loop iteration, while the y-axis represents the remaining positional error in pixels. At iteration 0, the system starts with 0.4 pixels. And then after the first step, it becomes 0.16 pixels, showing that the controller immediately corrects most of the navigation error. By the third iteration, the error reaches approximately 0.05 pixels, which is nothing but, see in the result we have got 0.046, just rounded off to 0.05. This demonstrates rapid convergence towards the desired position. After that, we see a small increase in error followed by a gradual reduction. This is the controller settling around the target rather than diverging. The remaining variation is due to the discrete pi updates and the chosen controller gains. Thank you.